So for this video, I'll be looking at some proofs by mathematical induction, and we have a few steps here. Our first step being prove true for the base case, or second step, assume true for some integer k. Third step, since we assume true for some integer k, we want to prove that the assumption being true implies the integer k plus 1 is true. And our fourth step is our conclusion. So now for example 1, we have proved that 1 plus 2 up to some n is equal to n plus 1 over 2 is true for all positive integer. So let's write out our summation. Our summation of 1 plus 2 plus 3 up to some n can be written as the summation of I is equal to 1 up to some n of I is equal to n plus 1 over 2. So now for step 1, we have proved true for the base case, which is n plus 1, which is n is equal to 1. So that leaves us with our summation of I is equal to 1 up to 1 is equal to 1 plus 1 over 2, and that is just 1 is equal to 2 over 2, which is equivalent to 1 is equal to 1. Therefore, it is true that n equal 1. So now for step 2, we have our assumption, and we need to assume true for n equal k. Is equal to the summation of I is equal to 1 up to k is equal to n plus 1 k plus 1, sorry, over 2. Now for step 3, we have, since we assume true that n is equal to k, we need to prove true for n equal k plus 1, and that is what we're going to do now. So prove true for n equal k plus 1. Recall at our summation 1 plus 2 plus 3 up to some k plus our k plus 1 term. Our 1 plus 2 up to some k is just our assumption, which is k plus 1 over 2, plus our k plus 1 term. And simplifying this, we have k plus 1, k plus 2 over 2. And if we notice that our n plus 1 over 2, if we had substituted k plus 1 for our n, we would have ended up with our proof, which is just our k plus 1, k plus 2 over 2.